people have expressed that Willow's ability to process potential outcomes is an indicator that alternate dimensions is a reality. Is that just crazy talk, or is it crazy talk? Is it people that don't actually understand the technology, or is this technology indicating some interesting potential realities of the structure of reality?
Okay. You and I, as analog humans, live in a three-dimensional world. Our brains are hardwired to understand things in three dimensionals. The mathematics, here's kind of an odd thing. The mathematics of 4 dimensions and 5 dimensions up to 8 dimensions is hard. But above 8 dimensions, the mathematics of dimensions above 8 becomes easy again. I don't know why that is. Maybe it's so abstract that it makes make math easier to understand. Now, we talk about 3 dimensions. You're familiar with the Rubik's Cube?
Oh, I've seen the bad boy. I don't know if I've ever finished one, but I definitely have spun it around and gotten frustrated.
Yeah. Well, so a little 2x2 Rubik's Cube.
I feel like I could figure out the 2x2. I don't know about that 3x3 though. The 2x2 looks a lot less scary than that 3x3.
So there's essentially 3. Well, there's 2 ways to figure it out. There's one way is not to figure it out, right?
Yeah, that's the one I do.
just random, and hope that it works and not know. There's a formulaic way where you're not really looking at the cube. I mean, you look at the pattern.
I was about to make a goofy joke. Keep going. Don't let me.
Right. So I mean, it relates to math in a minute, right? So you could look at this and say, oh, I want the white to line up. So I just have to turn it this way. There, I'm solved. Right? Rubik's invented this because he wanted his math students to think in 3 dimensions.
Okay.
Right? Visually, they wanted to think in 3 dimensions. So you can solve this by 3-dimensional thinking.
Okay.
Now the other way, which most people take, is essentially translation tables. So when you see a certain pattern, you say, "Oh, I do twist, 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 untwist," and then it's solved. So it's formulaic.
Right.
It's not visual.
Yeah, and they're not actually using the space. They're using the equation.
They're using equations.
They don't have the. Okay, I'm with you. Keep going.
Now, and myself included, I actually solve it formulaically. I enjoy understanding it visually, but that's too slow.
Right. Yeah. Well, you've solved it already. You know what I mean? It's the difference between somebody that's like playing a Legend of Zelda game for the first time and somebody that's played it 10 times. It's like,
yeah,
if you've solved it, then you just do. You don't have to be like, well, where's the key? You just go to where the key is.
Okay,
you gotta play a Zelda game if you haven't, because it seemed like you didn't get that reference. You'd freaking love it. You would love it.
No. In my downtime, I've actually been playing Zelda's Breath of the Wild, which we bought for the young kids so long ago. But it's fascinating, the breadth of the game.
Is that your first time ever playing a Zelda game?
No.
We'll talk about that.
Man. I never played them seriously. I mean, this one I actually am playing a little more serious, which
Oh, I see. Yeah.
I have. So you gain your game playing skills at 12 years old, right? For males. So at 12 years old, we had Pong. So my game playing skill is turning a dial.
I know what you mean. I tried to play like Final Fantasy 15 or something recently because I loved I like Final Fantasy like 7, 8, 9, 10 were a lot of fun for me. But the like way combat is just I'm so overwhelmed. It's too fast because the original was turn based. So I know what you mean.
Yeah,
I do understand
that kind of thing.
Yeah.
And so my nephew barely watches. He's disgusted with how I play Zelda because he's like, "You're so dumb. You're such a loser at this game."
You got to
like,
tell him to be more friendly with his communication. But I'm sure I get what you mean. He's frustrated watching you.
It's right. It's frustrating. Like I'm essentially doing the farm.
It'd be you watching me trying to figure out a Rubik's Cube. You'd be like, this guy, he
exactly. Hey, hurry up. Move. Let me do this. Yeah. Anyway, so let's get back to the mathematics. So we're kind of steeped. And part of the reason I bring up the Rubik's Cube is because it's a 3-dimensional puzzle. But with computer simulation, they've turned it, there is a 4-dimensional Rubik's Cube.
Oh, that would really give me a hard time.
Oh. Yeah.
You gotta share it. Put it on the screen here.
Okay. Let me find it.
Because I can't even conceptualize the damn thing. I just keep trying to think of it, and I just keep imagining a Rubik's Cube, the 3D version.
Let's see.
I have a knot in my back, and it is driving me bananas.
Well, yeah, stand up if you need to.
Well, I might just swing my neck around a little bit. Oh, fuck it.
See, I've actually played the... Let's see. This one, it doesn't match. It's close, but it doesn't match. I'll do a SketchUp thing and.
Well, anyway, okay, perfect.
And do a thought experiment with you.
Good God.
So here's the way they imagine it, right? Let's see. Let me load an app, and we'll come. Okay, there's a book, and it's an open domain. It's an open domain book, and it is called Flatland. And I actually find it a hilarious book. Hilarious.
Does it feature my boy Flat Stanley?
No.
You know about Flat Stanley?
I don't. All right, let's get... Okay, so in Flatland, the narrative of Flatland is you have this 2-dimensional world of shapes, and it's politically incorrect because
me and Flatland have some things in common sometimes.
It's part of the hilarity. It's part of the hilarity, and we will get banned by YouTube if I go into it too aggressively.
Okay.
But what they do is they say in Flatland, your intelligence is based on the number of sides that you have. So if you have and so some members of society are just a single line segment, and because they are invisible from a certain direction, they are required to waddle. Let's see if I should be able to. And then your soldiers are. Let's see.
I'm gonna send you a.
I need a better. I'm failing because I loaded an app I'm not familiar with.
I can see why that would be a problem.
So let's try this again. Because I actually do want to show. I do want to show something.
I want to see it. I'm not in any kind of rush. Everything I've got left to accomplish this week can be accomplished in the time left this week. So this is exciting. And you only have something like Willow get announced how often? How many every how many trillion years, John?
I know, exactly. Okay. Here we go. Let's see if I can rock this one. Share the screen.
Oh, share one more time. I misclicked. Thanks.
Okay, don't need that. I should probably okay. So in Flatland, they require let me make that a little bit thicker, but in Flatland, they require line segments to waddle if your viewpoint is if your viewpoint is straight on. They are dangerous if they waddle because they can pierce you, right?
Sure. Like, yeah.
So line segments are considered the least IQ intelligence, right?
They can bang into you and hurt you without even knowing what they're doing, huh?
Yeah, they just pop you.
I've met some fools like that.
Right now,
I know some cats like that.
Soldiers are triangles because they have a point, and they can hurt people, but you can still see them, and they're the least intelligence, right? And so,
like a brawny dude at the gym.
Yeah. So if you're a square, you're more intelligence than a triangle, and if you're everything's polygon, so they wouldn't have a star, but they'd have a pentagram, a pentagon, a hexagon, and so on.
The young dodecahedron. I was really excited.
Yeah, you're just more intelligent, and then in a certain sense, you want to, your circle is the highest intelligence, and it doesn't exist. Okay, so here's kind of the point of Flatland. So a three-dimensional object comes into Flatland, right? A three-dimensional object.
Yeah.
But from say a sphere. But from Flatland's perspective, it just looks like a circle that changes its surface.
Okay.
Right? A sphere in Flatland is unintelligible. Or it's the elephant thing, right? You have 13 blind yogis, and they all touch an elephant, and one says, "Oh well, an elephant is like a snake," because he's touching the trunk. And another one says,
Ah,
no, it's kind of a hard piercing sphere because it's touching the
yeah.
tusk. And then no, it's like parchment paper because it's the fold of the ear and so on, right? So each perspective is different. So in Flatland, the sphere that comes into Flatland is just intelligent as a circle, and it's like, it's so weird.
Yes,
Now,
so much of it isn't recognized.
right. And now I guess I'll do it as the star, right? The priest class of Flatland is afraid. They are in charge of their religion, and they're very worried about every 100 years a square will start spouting such nonsense as 3-dimension crap, right? They have two-dimensional.
Wait, is Flatland real, or are you trying to make a point? Keep going. Don't answer my question because they're gonna take me off YouTube. Keep going, John.
Read the original 1800s version. Do not read the modernized, politically correctized version.
Dude, I knew I liked you.
Okay, so every 100 years or so, and let me draw something. Okay, so let's say that this is this guy's house, right?
Who's
this square lives in a house, and the bedrooms are pretty simple because from Flatland's perspective, you can't see around the house, right? So every 100 years, a square who lives in the house and has comfortable furniture starts spouting 3-dimensional nonsense. And the priest class exists to keep people in orthodoxy, right? Keep people in the conventional wisdom of 2-dimensional mathematics and 2-dimensional existence, and line segments have to waddle because it's so dangerous. They just right. Pierce things.
There's no way they could learn the line segments.
Right.
Or maybe if you put a bunch of line segments together, do they make anything if you get a bunch of line segments together?
Well, I'll come back to that.
You could lean a couple line segments up to each other and make a triangle.
Well, but in Flatland, these polygons are all existences.
I know.
Anyway, and maybe you've discovered what the birth rate is. If you take lines and move them together, then you get a new entity.
Maybe.
Okay, so this sphere comes into Flatland and picks up a square, and from a 3rd-dimensional perspective shows the square Flatland. And the square is like amazed and says, that's my house, and I can see into my house. I can see through walls. This existence is crazy. And the square comes back to Flatland, and the priests immediately try to kill him because that's what religions do, is they kill new perspectives. They keep you in orthodoxy, right?
In Flatland.
And he's like, no. Yeah, in Flatland. So the square is like, no, I have a new way to construct Flatland, and my house has an inside that is perceptible from a different dimension, right? And he's doing all these heresies, these Flatland heresies. And the sphere comes back and talks to tease the square some more. Yeah. And the square says, oh, it's so wonderful. You've opened my horizons to 3 dimensions, and it's wonderful. And I want you to show me 4 dimensions. I want you to show me the inside of you like you showed the inside of my house. I want you. Yeah. And the sphere is like, that is heresy. There's only 3 dimensions. And the sphere comes back. This is the spoiler. You should still read Flatland because it's.
Here, let me write.
I'm going to go through it, so you don't need to read it. But the sphere comes back and says, "You're right. If a 4-dimensional being came into my 3 dimensions and pulled me out of it, so I was aware, then of course you could see the inside of the sphere and so on."
Right.
Okay, so let's get to the money thing.
The money thing.
No,
What are we
let's see.
getting to?
Select all. Okay, so if you have a point, right? I'm going to inexpertly draw a point, right?
Okay.
If you have a point, it would be considered 0 dimensions, even though it exists,
Sure.
right?
Yep.
So it has one vertex. It has no length, right?
Yeah.
If you drag a point along, I'm doing it inexpertly, so let me do this expertly. Let's see. Well, I guess I'm going to do it inexpertly. If you drag a point, it becomes a line. And as a line, it has 2 vertices, right? So text vx2, right? When I add a dimension, I get twice as many vertexes.
Okay.
Okay, now let's say
I remember this.
now I'm gonna slide this line in another dimension. So sorry, this is D0, right? This is down a little bit more. Well, this is D1, right?
Okay.
So D2. So I am going to slide the line in another direction, and I get a square.
Yeah.
So my vertices times 2 go to 4, and my sides, if you will, go to 4 as well.
Sure.
Right. So I've introduced a new metric here. Edges x4.
Yeah.
Okay.
That's our square
So
buddy.
now,
Flatland. I recognize him. He's more of a
Yeah.
rectangle here, but I recognize him.
so now let's do D3, right? So D3 is a cube, which this one actually, let's see. I started wrong, so let's delete this. But isn't that cool? This has cube stuff.
Yeah, this is nuts. I can't wait to see where this goes, honestly.
Okay, so here's cube. Let me
I imagine
move it.
where it goes are those lines off into the.
Okay, so how many vertices do I have? Well, I have to do times 2, so I have 8 vertices.
Yeah. Wait.
Right?
Yeah.
D8. And how many edges do I have? I have to multiply by 4, so I have 16. Is that true? 1, 2, 3, 4, 5, 6, 7, 8. It's 12.
Yeah.
So I have 12 edges.
Because they share one. Each of them share one.
So what's my formula? 1 to 4 to 12. 4, 8, 12. And then the other thing I have is sides, right? So in in 0 dimensions, I only have a point. In 1 dimension, I have an edge, right? In let's see. So V2 edge 1. Let's delete that. This has I like this tool, but I'm not used to it either.
It is all good, man. We are on no.
D4, D4.
Usually, this thing exists within a time limit, and now that we're outside of that,
Okay, so what's added to? I now have surfaces, right? I have 6 surfaces, 8 vertices. So the vertices are times 2.
yeah, I agree.
Okay. So now the problem is taking the flatland example. So what is D4? Now in school you have falsely learned that time adds the 4th dimension, but time does not add the 4th dimension, because when you add time, you don't double the vertices, right? What we know from this formula is the vertices have to go to 16.
Yeah, to get another dimension. Well, what's the equation
Yeah.
for the edges?
See, I'm gonna guess 3 times.
No, it can't be. It can't be, because 1 times 3 isn't 4. It looks like it's maybe double. No.
I'm going to guess times 3. Because here's the point.
I see why you're guessing times 3, because there weren't the sides and the vertices and the edges don't present until certain starting points, and D1 would be an edge starting point, because D0 is 0 for, it's 1 for vertices, but it's 0 for edges.
Oh yeah. So the metric, I'm just guessing 36. And then what about your surfaces?
Oh heavens.
Here's the point. Here's the point. You saw how we did the sliding trick, right? You had a point, you slided it in 1 dimension, you get 1 dimension. You have a line, you slide it in a 2nd dimension, you have 2 dimensions. You have a square, you slide it in 3 dimensions, you get 3 dimensions. How do you slide the box into the 4th dimension? Using a third dimension vector, right? So in each case, I used a vector to slide, right? Yeah. In the D1 case, I slid it in this direction. Then I slid the whole option in this, and so on. As humans, we think in 3 dimensions. Where do I slide?
Is it like diagonally out?
All at once.
Right. Each one of the vectors needs to expand outward and inward. Is that right?
Yes. And here's how some scientists. Let me. I think I can find this.
I'm freaking pumped about this. This is the first. This is neat. This is neat.
Okay. So I'll share this screen, because even though it's hard to read, it makes the point in incredible. Oh, let's see. Okay. This gives you incredible, mind-blowing. So this is a human.
Good. Yeah, tesseract. Okay. I see.
Yeah, this is a human interpretation of mapping 4 dimensions into 3 dimensions into 2 dimensions, right? Because I have a 2-dimensional screen here.
Yeah.
Now, as humans, we will make the two dimension to three dimension jump, which is why the fallacy of time being the fourth dimension is a human. It's a human mistake.
Okay. Yeah.
Because all time does is animation. Now, kind of back to the see. So what they've
Oh.
done here is they've stretched the cube in a third dimension as if it were a fourth dimension, right?
Mm-hmm.
And then, but the point is that from a three dimension point, those two vertices are the same, right? You
Oh
could pick any
God. Yeah, I see.
vertices connected by a line, and they
As
would be
it
the same.
as it spins here, like as it, oh my goodness, or as it rotates. I guess spin isn't the correct thing, but I
Yeah, because
say it
we
again.
can't
I think
talk
I
in
see what
four.
you're saying.
We can't talk in four dimensions. We have three dimensional understanding.
Yeah, we don't have. Yeah.
Okay, so where am I headed?
I don't know, but I'm stuck watching the Tesseract. Where are you heading? I was asking you about. So the question was: some people have suggested that Willow is a
Oh yeah,
an indicator of multiple universes. I think is here. Let me. Well, I might have deleted my note now that I asked you the question. Let me pull them up.
yeah. That's so. The reason I was bringing up mathematics is that in quantum theory, to get to the next step, they use 11-dimensional mathematics.
Okay. Yeah, that's it.
And
The multiple dimensional theory.
right, and then they simplify them back into 3 dimensions by ignoring 7 dimensions.
Okay.
Or ignoring, they ignore they keep 3 and throw away 8.
I don't know if I quite understand exactly what you.
Well, they do a human simplification trick. They just say, okay, there's 11 dimensions, and we're just not going to care about 8 of them. They've neutered their mathematics.
I understand what you mean. So for what we don't have communicatory things for, or it's just not useful.
Yeah, now they do that in a practical sense. But in the imaginary sense, if there really are 11 dimensions to the universe, that's a lot to work with. And Nikola Tesla did it. He did an interesting experiment that they don't replicate today. So he did a
Drop your screen share because I got you slightly. Here, talk for me.
Well, if I were to screen share again, I would go back to the doodle pad.
Hop out of the restream and come back in because your audio and your video is slightly off, and I want to make sure that that's right for you. And it throws me the hell off. No, you may not be able to. Okay, good. Give it a little test.
That's better.
Yeah, it's better.
Better-ish.
It's just gonna be what it is.
Okay, so Nikola Tesla did so if you were to, speed of light, let's get my thing back on. Okay, so in a crude drawing, your speed of light is a wave, right?
Mm-hmm.
So if you measure the wave, in essence, trough to trough, it has a certain speed that it travels. right?
Okay.
And so that's the classic measurement for the speed of light.
Okay.
So this would be if you thought of this as a hose and or a string and you were waving it back and forth, you would have a wave pattern in the hose.
Sure.
Right?
Sure.
Now Nikola Tesla said if you took that hose and you tugged it, you would have a different speed. And his experiments showed that wiggling the hose back and forth at the speed of light was fine. Tugging the hose was faster than the speed of light.
Oh.
So that was his claim. Now, in current physics, Einstein's starting to be thrown out. Relativity is starting to be thrown out. In other words,
Wow.
about every 100 years, physics turns on its head appropriately, and new theories come in. You know, you had Faraday, and then you had Newton, then you had Faraday, then you had Maxwell, and then you had Einstein.
Mm-hmm.
And it's long overdue for Einstein to be thrown out. And there are some relativity measurements that show that Einstein was wrong. And part of the problem here is instead of taking the opportunity to rework their theories and come out with the new metaphor, they have been adding a fudge factor to keep the old metaphor. And the fudge factor is dark energy and dark matter. And the reason I call it a fudge factor is the measurements, the observations are 93% wrong. And
What?
so if you add a fudge, so what happens is as you measure the rotation of a galaxy, if the current physics, including relativity, were correct, the speed of the stars in the galaxy are 97% wrong to the formula.
Really?
And so they have to add dark matter, but that by definition you cannot measure, right? You have to add a fudge factor called dark matter to correct your observations back into the formula. And they have another thing they call dark energy. So they cannot explain the expansion of the universe as they observe it with the energy that they observe. And so they have to invent an energy that by definition you can't see to make the formulas match the observation. Now, in true science, and I would argue to a large extent, we've become a post-science world. In a true science form, you would take the observational evidence to throw out your theory and come up with new theories to new exciting theories to match the observations.
Right.
And instead, they've crippled the scientists, if you will, because you don't get your PhD unless you tout the existing dogma. Right. And the same thing happened. I mean, you can look back in history, and the same thing happened with Darwinism. The same thing happened with continental drift. There was a day where before that day, you were an idiot and deluded if you thought continental drift was real. And within a week, because of the evidence, they couldn't deny it anymore. And then you were an idiot if you believed it wasn't real.
Right.
And so that's part of why they say science advances one gravestone at a time. That the dogma keepers have to die out for the new exciting theories to come forward. That there's a tipping point, if you will. Okay. And this kind of comes back to, here IBM is doing old dogma Is Google doing new dogma? Maybe. I don't know.
Yeah.
They seem to be moving faster than IBM. Maybe they've looked at the quantum theories and applied some new theories to it that aren't in the dogma.
Sure.
And you look at the string theory, which is 11 dimensions, which is supposed to, it's supposed to replace relativity and Newton and all this kind of stuff. And yet, in a dogmatic sense, they keep rolling it back to 3 dimensions. Well, if you embraced the multiple dimensions, you might be able to do additional things. I mean, they observe the Hall effect. They observe the Hall effect. You can see it in vacuum tubes. In an analog sense, you don't know what's going on in a silicon sense. But if you add some of those other dimensions that string theory has, you might be able to explain what the Hall effect is in a concrete fashion instead of just saying it's quantum magical. It's the same thing with the Schrodinger box. We observe it in a quantum magical sense, but if we add some additional mathematics and we try it out and we observe it to be true, it would change and improve our understanding of what's going on, and it would go out of the magic and into understanding. And so when I hear humans say this supports multiple dimensions, I think the human is still in magical thinking. And yet you can see the evidence of multiple dimensions in front of our eyes as scientists wrestle with this.
Yeah.
And so there may be some truth to it, just not in the way we think it is. We don't know how to think about it because we can't think in multiple dimensions.